Welcome and hello. This is a video exercise in HEC HMS. And in this exercise, we are going to be talking about interpolated temperature. This exercise demonstrates how gauged temperature measurements can be interpolated to create a gridded temperature data set and how it can be applied. All right, what we have here is the web page that we'll be using. Go ahead and go to this web page if you want. I will leave a link in the description if you're interested in following along. All right, so here are the instructions. There's an introduction. First thing we want to do is click on this Truckee River initial.zip file to download it. Okay, that's downloaded for me. So let's see what we got. And Truckee River initial, Truckee River, and then here are the files and folders I expect to see inside of an HMS project. So I'm going to go up one level, find a location on my computer where I want to move that to and keep it permanently, and then just drag it over, wait for it to copy. And then once that's copied, I can delete the zip file and we're good to go. All right, let's go ahead and open up this Truckee River project in HMS. So here we go, HMS, File, Open, and then I'll click the Browse button. And let me navigate to that directory. Here's the project, and then the Truckee River .hms file, select, and then Convert Project. If you see that pop up, it just brings it to the current version, and it should work. Here we go. So we have one basin model. I'll go ahead and click on that to see what it looks like. And here we have our familiar Truckee River basin model up on the map here. I'm going to go View Map Layers, and I'm going to toggle off a few of these layers here. So 1 second. Okay, I toggled off a few layers. The first part of this instructions tell us to inspect the temperature data, first by going to DSS View and then later to HMS. So I will do just that. I'll open up DSS View and then navigate to the January 1997 gauge temperature.dss file. Here's our project, so I'll click into that, the data directory, and then right here, the second file is January 97 gauge temperature.dss, and I'll click open. What we have here are 5 different paths, and these represent the air temperature at different locations nearby our basin. So if I click on the plot button, here we have all the data. It looks like there's 3 months worth of data here. Let me go ahead and just zoom in on a week or so. All right, so it looks like all the data is here. I believe this is hourly data. I can go ahead and go File, Tabulate. Then here are the values. So it looks like it's going from December 1st of 96 all the way through February 27th of the next year, 1997. The path name parts are also important. Part B here represents the location. Part C says temp dash air for air temperature. Part D is the date range, which I can't completely understand why it's a little bit different here, but it's all good. Part E is the hour. That says 1 hour. This is the time increment because this is hourly air temperature data. And then part F is left to be the source, NCDC. All right. In the next step 2, it says to look at the temperature gauge data in HMS. So let's go to HMS. And then if I go up to the Watershed Explorer, we have time series data and then temperature gauges right here. These are the 5 temperature gauges. Now, I don't know if you noticed on the map though, but if I hold down to pan and then continue holding down the left mouse button, at least for me, I'm seeing the 5 different temperature gauge locations. If I let go, those markers are still on the map, but they're kind of hard to see because they're covered up by a number of the other map elements. But here they are. You can see 3 of them are actually within the watershed, and then 2 of them are beyond east and west of the actual watershed. If I click on one single gauge in the Watershed Explorer, the component editor shows me where that data is, which is exactly where we were looking for the DSS file name and path name. It also provides the elevation of that temperature gauge station, the reference height, and then the latitude and longitude. One unfortunate thing I discovered when preparing for this exercise was that 2 of the gauges are mixed up. They are the Fallon Nass and Lake Tahoe. So for instance, Lake Tahoe right here has a longitude of negative 118.7, which is this dot right here, which is the far eastmost temperature gauge location in our model. If I just look at this longitude in degrees and click on all the others, we have 120.7, 120 even, 118.7, that was the one we just looked at, Lake Tahoe. 119.77, and then 120.13. The Lake Tahoe gauge is supposed to be down here, but it's all right. We can just continue on. The point that the instructions make at this juncture is that for the interpolated temperature grid generation to work, these locations for latitude, longitude, for all the temperature gauges need to be assigned, as well as a few other things. Specifically, there needs to be a coordinate system, which is right here. And also the subbasins need to be geo-referenced. So for instance, if I click on this southernmost subbasin here, which is Upper Truckee River S10, we have the latitude and longitude, and we're also using the Maud-Clark transform method. So those are all requirements if we want to view the spatial results, which we will get to later in the exercise. All right, the next task in the instructions tell us to create the interpolated temperature grid. The temperature grid is created when a simulation is run and when its meteorologic model uses the interpolated temperature method using at least one temperature. All right, so let's go ahead and see what that's all about. We have a meteorologic model right here already generated for us. There's only one, and it's right here. It's using interpolated precipitation and gridded Hammond for evapotranspiration. And what the instructions tell us to do is select interpolated temperature right here. So once we make that selection, we have an icon for interpolated temperature in our Watershed Explorer. And then what we want to select is inverse distance. The instructions also tell us to use laps and then type in negative 3.5 degrees Fahrenheit for every change in elevation of 1,000 feet. All right, after that, we also want to select the gauges. Those are going to be all 5 of the gauges. All right, and now that I got those in, I'm also supposed to, once those are in, I also want to type in 31 miles for the radius of influence. And I'm typing them in, but there they are. Okay, just needed to make that column wider. And we're good. All right, so let's just double check everything before we run the simulation. I'll go ahead and click Save. If I navigate to the project directory, what I'm looking for is a .dss file relating to the meteorologic model name. So our meteorologic model is January underscore 1997 underscore gauge interp. Currently, we do have a DSS file with that name, but we can delete it and it'll be regenerated when we run the simulation. So let's just go ahead and demonstrate that. I'm going to delete that DSS file. And then let's do some final checks here. So HMS, if I click the compute tab, I can see the simulation that's already set up. So it's going to be using the January 97 basin, January 97 gauge interp MET model, and then our control specification is Jan 97. So let's see what that looks like. Control specification. This is going to be from December 27th through January 15th of the following year at a 1-hour time step. All right, let's go ahead and run that computation. Right click, compute. All right, that looks successful. All right, so first things first, let's go ahead and see if that DSS file was generated. I don't see anything here. Let me just right click, show more options, refresh. Right here, Jan 1997, gauge interp.dss. I'm going to go ahead and go to DSS view and then open up that file. So right now I'm in the data directory because we were looking at our temperature time series data. But if I want to go up a level, that is where the simulation DSS files are stored. I'll go ahead and open up that one right there. We have a lot of data for precipitation, but then further down, here is our temperature data. This is our temperature grid. To make it easy, I will just filter on part C for temperature right here. And we have 481 records. That represents hourly data for 20 days, plus one additional record. All right, I'm going to highlight all those records and then click on the graph tab. And this is a little wonky looking, but if I do hover over this green cell, I do see values, which represent temperature in Fahrenheit. And this is just the first hour. So if I scroll through, then I can see other data. It doesn't really simulate well because we have some huge numbers right here. And I already tried using the sanitizer tool, wasn't able to get it to work. If you're curious what I mean by that, I'll show you. If you go to HMS or just HEC Vortex standalone, you can go Tools, Data, Sanitizer, and then I need to navigate to that DSS file. Okay, here's the project. Here is the gauge interp.dss. All right. This is precipitation data first. I kind of wish there was a filter on this utility because there's a lot of records here. I'll just go ahead and select that first temperature grid and then let's see, move it over, click next. And then if I want to filter by threshold by removing extremely large numbers, I can click this filter values above. And if I say anything over 100 degrees Fahrenheit, which of course would be any of those extremely large numbers, this is the Lake Tahoe area in January, then I could just had no way to say no data. I can put in a number, I could put in negative 9999, but then that would actually be understood by the program to be negative 9999. I can't just put in no data. So there may be a way around this. I just may not fully understand all the ins and outs of the sanitizer wizard. All right, anyway. Task 4 says to view the simulation results. We already saw them here in DSS view in the form of this plot here, but this is not particularly satisfying. Back in HMS, you'll notice with the simulation run, we were recording the spatial results. If you don't see the spatial results toolbar up here, you can go view toolbars, make sure spatial results is toggled on with the check. And then what we want to select here is air temperature. Click OK. Right, so that came in. Let me go ahead and make some more room here. Right now, the range is probably too large. Again, 100 degrees Fahrenheit doesn't make sense. So this point ranges from about -4 to 50. I'm just doing some spot checking here. This range is from 0 up to 65. Okay, nowhere near 100. Let's go to the south end here. We got 0 up to, again, 65. So let's go from maybe -10 to 65. So I'm going to reset this scale here so the colors look a little bit better. I'm going to click on this gear icon, this button here with like a settings button. All right, and then for symbology, I'm going to click symbology tab and then stretch. That's what I want. The maximum value will be 65. The minimum I'll say is -10, and then apply, and okay. All right, let's go ahead and run the simulation through. Remember, this is air temperature ranging from -10 to 65 during our 20-day simulation. So that's December 30th, 31st, January 1st, January 2nd, 3rd, 4th, 5th, 6th, so on. All right, looks good. What you saw me do earlier was if I have a point of interest, I can go ahead and just right click, plot spatial results, and I see the time series of air temperature. Let's move that right there, sorry. And that's over the course of the 20-day simulation for just that one spot. One method of validating interpolated temperature values is to compare those values with other gridded temperature products, such as the PRISM dataset from Oregon State. And this is what the instructions say at the very end. This right here is the Upper Truckee River S10 temperature. So this is the average air temperature for a subbasin. In fact, I'll show you how to bring that up. We'll go to the results tab right here and then expand our simulation. Click on that Upper Truckee River S10 subbasin, and then just go down to air temperature, which is right here. Here's that plot. We can bring it up into its own window right here. But if we wanted to compare this data with the PRISM data, then we can download the PRISM data from the website, then use some of the tools in HMS so that it can be joined at this same sort of plot for comparison. So let's go ahead and do that. I'm going to close this, head over to PRISM. I'll go ahead and leave a link to this page in the description of the video. Click on recent years. Now we want the end of 1996 and early 1997 for temperature. So click on mean temperature right here. And then down in temporal period, we're going to choose daily data. And I'm going to start with 1996. It's right there. And then we're going to go December and then download all the data. So once that's downloading, I'm going to go ahead and change the year to 97 and then the month to January and then start that download. While that's happening, I'm going to go back up to my project. Here's the project. Here's the data directory. I'm going to create a whole new folder in this directory here, or folder called Prism Data. And then I'm going to open that up and then just move in all these .bil files I downloaded for December 96 and for January 97. All right, so those are moving over. I can go ahead and remove those files once they're copied over into my project. Next thing I want to do is extract just the subbasin for that Upper Truckee River S10. So back in HMS, what I have is a number of subbasins. Let me go ahead and toggle off the results. And then I'm also going to turn that terrain layer off. That's a little bit distracting. All right, so what I want to do is look at this Upper Truckee River S10. It's the southernmost subbasin, so I called it lower, but we're going to go ahead and export the subbasins layer. Next, I'm going to call it shape files, and I'll put it in my GIS directory. Here's my project. Here's the GIS directory. All right, so I'm just going to call it subbasins and then click save. Okay, finish. Now I'm going to open up QGIS, create a new project. I'm going to save this in my GIS directory as well. Here is the project, and then here's the GIS directory. I'm just going to call this QGIS. Now I want to bring in that shapefile that we just exported of the subbasins from HMS. So we'll go layers and then add layer. This is a vector. Then let's navigate to our project's GIS directory. Okay, here's the project. Here's GIS. And then here is the subbasins shapefile. Okay. So here we have the shapefile. What I want to do is create a shapefile of just our subbasin to use as a clipping tool, a clipping shapefile for all that prism data. We don't need the entire United States. We just need this little area right here. Now, there may be other ways to do this, but I'm just going to go ahead and create a polygon shapefile, sketch it out, export it, and then call it good. So to do that, I'll go Layers, Create Layer, New Shapefile. And then I'm going to click on Polygon and then navigate to, here's the project, here's the GIS directory, and I'm going to call this Upper Truckee River S10.shp and save. Okay, so that is ready for editing. I'll click OK. And then, okay, thank you. I'm going to select that from the layers panel, click on the edit pencil, and then click on the add new polygon shapefile. And now I'm starting to sketch around this subbasin. Okay, I'm using a little bit more area than I need, and that's going to be all right. And then I'll just go ahead and right click off to the side, give it an ID, and go ahead and save and stop editing and save my QGIS. I think that's all I need to do here. I'm going to go ahead and bring this shapefile into my HMS and then just confirm that it looks correct. I'm going to go View, Map Layers, Add. Here's the project. Here is the GIS. Here is the shapefile that we just created in QGIS and select. Okay, looks good. So that is the outline that we're going to use when importing all that build data from Prism. We're ready to do that now. I'm going to go File, Import, Gridded Data, Importer. All right, so here's the dialog. I'm going to navigate to those Prism files. Here is the project, and then here's data. I have my Prism data right here. That's where I have all my bill files for the temperature, hourly temperature data. I'll click OK, and then next. T mean is what I want. It's the only variable for average temperature. And then next. Okay, so this top field right here is the shapefile. Here's the project. Here is the GIS file, and then here is the shapefile we're going to use to clip just the area of temperature that we want. All right, that looks good. So I'm going to leave the projection, the cell size, everything just as it is. Those are optional fields. And then the destination, let's see. So what I want to do here is I'm going to create a new DSS file. So that's going to be in my data directory, Prism data. I'll just call it Prism data instead. Prism data.dss and open. I'm going to call it Prism data underscore. I think it has to be a unique name so it's not confused with the folder. Let's click open. Okay, I think that looks good. I'll just call part F Prism and then next. All right, I'll close that. Let's go to DSS view and take a look at what we have. Open. And then click on data. Now prismdata.dss is right here. What I have here is the temperature data. We have 62 records, so that would be, that would be once per day for the 2 months. So we have all the way from December 1st through the end of January. But we only need about like 20 days because the simulation isn't 2 months long. It's just a subset of that. Anyway, let's go ahead and click on the data and see what it looks like. I selected it all, then clicked on the graph icon. And this looks a little awkward for air temperature, but if you hover over the values, it actually does look correct. Let me check the grid info real quick here. Yeah, so we're in degrees Celsius, and it's just a 7 by 7 grid based on the shapefile that we used to clip the data. So I think everything here looks good. Let me just cycle through a few more hours of, or days, excuse me. This is days. What we want to do is convert this grid to a time series data set using like the average value from the grid itself. And that is what the grid to point tool does in HMS. So after we convert it to a time series, we can compare it with our simulation results and then call this good. Back to HMS. Okay, thanks. We'll go tools, data, grid to point. Now what I'm going to do here is navigate to that data we were just looking at that we downloaded from Prism and then use the importer tool to convert it to a DSS. Here is the project data directory, prismdata.dss. Okay, so this should be our 62 records for air temperature, but just for that area, just for the subbasin of Upper Truckee River S10. I'll move them all over to the right panel, click next. Now for the zones shapefile, this is going to be the shapefile of the subbasin once again. So here's the project. And then in the GIS directory, I'm going to use this shapefile. That looks good. I'll click next. Select the destination. Here's the project. And then here is the data directory. I'm going to put it in the prismdata.dss as well. And then click OK. So this is a time series data set representing the average temperature for those 2 months. I'm not sure really what to call it. I'm just going to call it grid to point. I may end up renaming this, but as long as it's unique, it won't actually override any records. And next. Okay, looks good. So click close. I'm going to go to DSS view and take a look at that data. Okay, so I'm already in the correct file, prism underscore data underscore .dss. View, refresh the catalog. Now in part F, I can just filter to grid to point. Now let's see what this data looks like. Okay, looks good. It's the correct numbers. What I want to do is change the type because I'm looking for something that's more of a bar graph with a constant value for the entire day, which is easy. We'll just go up to edit. No, hold on. We can't do that from here. Let's select the record, which we do, and then click on tabulate and edit, allow editing. And then for instantaneous value, I don't want to use that for a daily temperature. I want this to be average period. So I think I can type in PER.AVE or AVER. Let's see if AVE works. So I could look this up, but haven't done it in a while. File, save. That looks good. Fahrenheit. Let's go ahead and look at the plot. Okay, perfect. This is what I was looking for. All right. Well, now we can make that comparison between this time series data set with our calculated air temperature grid data for that one subbasin, which is only going to be for about 20 days, kind of in this time range right here. I'm going to go ahead and just grab that data from DSS view. So we know it's in the output DSS file named for the meteorologic model. Okay, here's the project. And then if I navigate down to this file right here, it should be in here somewhere. For part C, I'm going to change this to temperature, or I believe it's air temperature. So if I click temperature, yeah, so this is the grid data. This is not the temperature records I want. What I want to select for part C is temperature dash air. All right, perfect. Now for part B, this is where I can filter by the subbasin. So we want Upper Truckee River. There it is, last one. And now we have 2 records. Let me take a look at the data here. Okay, it looks like the exact same data. We just have 2 records of it for some reason. I'm going to copy this record over into my prismdata.dss. So from here over to here, I'll go edit, copy to. This is perhaps not the most efficient way to do it. If I had to do this 100 times, I'd figure out a better system. But for just doing it once, this will be fine. Here's the project. Here is data. And then here is the prismdata.dss. That's been copied over. I can use this part B as a filter for Upper Truckee River because I think I have a lot of records in here. Let me go ahead and remove the filters, view, refresh the catalog. And then for part B, Upper Truckee River, I just want to rename part B to be the same thing so I can use it for a filter. just going to go copy, and then I cancel that. Then let me clear the filter, go back to part E, grid to point, rename. I'm not sure why it says 1 here, but I'm just going to give it something more meaningful like Upper Truckee River, and then OK. It's been renamed. Let me clear that filter, go back to part B, Upper Truckee River. Thankfully, now I can compare the two data sets I've been working so hard to compare for so long. And here we go. Here's some meaningful results. I'm going to zoom in on just the 20 days that we have data for both data sets. And sure enough, it looks pretty good. I'm going to make the plot lines a little bit thicker here just to make it easier to see. Okay, apply and OK. All right, sure. Certainly, we have a little bit warmer period the last week of 1996, followed by a little bit colder period for the first half of January 97. The red line here represents the hourly temperature data that was created using the interpolation, and then the blue line is the prism data, which we're using for a comparison. The website instructions show us this line right here, so I guess I got my colors mixed up. Go up to View, Plot Properties, and let's change the blue to a red. Then let's change this red to a blue. Apply. Okay. All right. Yeah, these plots should look similar. Let's say I got to zoom in a little bit more, just maybe right there. All right. Yeah. So anyway, that's how they got that data. Sometimes I like to take a little extra step and explore on my own and do a little bit more work. Helps the learning process. But this is the end of the exercise. We experimented with creating a temperature gridded data set using the time series data from 5 separate temperature grids in the Lake Tahoe area basin in California.